Okay, just want to go through a few chain rule problems to give you a sense of how they could be attacked and kind of finding some method to all the madness with this stuff, because it can certainly be a little confusing, but it can also be very obtainable if you just kind of stick with the process. So the first one we have is a trig function that's being squared. We've got essentially, if you think about what's happening to x here, the first thing that happens is it gets multiplied by 3, and then it's going to have the tangent applied to it, and then after that it's going to get squared. So we've talked about how when we're doing chain rule problems, functions of functions of functions, we want to work from the outermost function to work our way in. So the outermost function is this squaring. So if we're going to find f prime, we want to work first on that squaring. So we're going to bring the 2 down in front. And the tangent of 3x just kind of goes along for the ride. So we get the tangent of 3x, and now that's being raised to the first power. And you normally wouldn't put a first power up there, of course, but just kind of showing you that we've just essentially used the power rule to bring the 2 down in front, drop the power by 1. So now we've kind of achieved the derivative of the squaring process. So we kind of crossed that out, and we focused on what's left, which would be the tangent of 3x. So we say, okay, what's the derivative of this outermost function, the tangent function? At this point now, that's the outermost function. And the derivative of tangent is secant squared. So we multiply by the secant squared of 3x. And now we've completed that derivative, so we can kind of cross that off our list. And now the only thing left is the tripling function, the multiplying by 3. And of course, the derivative of 3x is just simply 3. And as far as the simplification goes for these guys, there's not too much to do. Just any constants that are lying around, you can multiply them together. So I would write this as 6 tangent of 3x multiplied by the secant squared of 3x. And that's our solution. So our next function here in number 2 here is x comes in, and it first gets doubled, multiplied by 2. Then it gets the cosine applied to it, and then it gets signed. So it's another one that's 3 layers of functions. And so we start with this outermost function, the sine function, and the derivative of sine is cosine. So we've got the cosine, which is the derivative of sine, and we're not going to mess with the stuff that's inside. Just kind of goes along for the ride. We've now taken the derivative of sine, so we work on the next function layer, which is the cosine. That's right in here. And the derivative of cosine is negative sine. So you might be tempted to write negative sine of 2x, but you really want to make sure that you show parentheses to make sure that it's clear that we're multiplying this stuff by this negative sine of 2x. Now we've taken the derivative of cosine being negative sine, finished with that, and we finish up by multiplying by the derivative of 2x, which is just simply 2. And again, similar to the first problem, we're just going to take this 2 and this negative 1 that's there and put them out in the front, and then just rewrite cosine of the cosine of 2x multiplied by the sine of 2x. And there's our answer for that guy. That's f prime. And now lastly, we have this function. It's a rational function that involves a radical in the denominator. And although technically this appears to be a quotient with a numerator and a denominator, just having done this for a long time and seen a lot of different students struggle with the quotient rule, I think it might be advisable to rewrite this function as a product of 5x and then 2x plus 2 being raised to the negative 1/2 power, which accurately represents the original function. And then we can just sort of think of this function as a product of 2 functions. So for our product rule, which is what we're going to apply, we will say that f prime is the derivative of this first function, which is the first function is 5x, so its derivative is 5. The second function just goes along for the ride, 2x plus 2 to the negative 1/2. Then we add the first function, 5x, times the derivative of the second function. So for the second function, this is where the chain rule kicks in. So we're going to bring the power down in front, negative 1/2. We have the 2x plus 2, which just remains intact, and we reduce this power by 1. So negative 1/2 minus 1 is going to be negative 3/2. And we're not done yet, because now we finally go back and take the derivative of what's inside. The 2x plus 2, the derivative of that is just simply 2. So we now want to clean this up, because we've done the calculus part, but usually we want to express these derivatives as like a single simplified fraction so that we can do some more fun stuff with them later on in chapter 3. And what I recognize about this is it's kind of been rigged, that we have a 1/2 here multiplied by a 2, or negative 1/2 multiplied by a 2. So I would probably clean that up just to be -1. But I guess over here in this first term, I would say this is 5 over 2x plus 2 to the positive 1/2 as it goes down in the denominator. And then we're adding this second expression, which has the 1/2 multiplied by 2, so they cancel each other out. So we're going to get a negative 5x, which is from this guy right here. And that's going to be over 2x plus 2 raised to the positive 3/2 power. So 2x plus 2 to the positive 3/2 power. So now we've accurately got everything accounted for. The only problem is we don't have a single fraction. We've got two separate fractions. So we want to add these two fractions together. So you'll find there's a really, really common scenario that you have these common bases, 2x plus 2 in this one and 2x plus 2 in this one. Only the powers are different. So we need to get another whole factor of 2x plus 2 over here so that it's the same as this one, being to the 3/2. This one's only to the 1/2. So what I'm going to do is take this factor over here on the left, and let's just say, let's give it another factor of 2x plus 2 to both the numerator and the denominator to make it legal. And now both have 3/2 factors of 2x plus 2. So that's going to be our denominator, 2x plus 2 to the 3/2. And now I can distribute the 5 here and here to get 10x plus 10. And then we're subtracting these 5x's. And so our numerator is 10x minus 5x, which is 5x. We got a positive 10 here, plus 10, all over this expression, which is the square root of 2x plus 2 cubed. So I'm going to write that as the square root of 2x plus 2. I'll put the cubing on the outside. Doesn't really matter if it's outside the radical or inside the radical. But there we go. Nice, tidy fraction all set for us. So these problems are comparable to anything you might see on a test, probably tougher than things you might see on the AP exam, but really 3 good examples to kind of get you through chain rule problems that involve a couple of layers.